Let's take a look at homework from your lab assignment, section 11.3. This is problem number 2. They want us to use the integral test to determine whether the series is convergent or divergent. The series starts with n going from 1 to infinity, and this is n times e to the negative 12n. So the integral test, remember, requires us to write your series, the sequences in your series, as a function, and we want to know what that function is. So that function, if you remember, would be x times e to the x, or e to the negative 12x. For integral tests, you need your function to be continuous, positive, and decreasing. So as stated in the statement of the integral test. And so now our task is to integrate this. In order to integrate this, we have to go back and remember our integration by parts, or one of the formulas in your book that has x times e to some number times x. So we're going to use integration by parts. We're going to let x equal to, well, like I said, let's just use a formula. And what do we have here? A is equal to negative 12. So we're going to have negative 1 over 12 times x times e to the ax. So that's negative 12x. And then we have a minus. And then 1 divided by negative 12 squared. So that's going to turn positive. And then that's 12 squared is 144. And then times e to that same power. And then we have a constant, but that's for the indefinite integral. Here we're going to supply the limits of b to 1, or going from 1 to b, and then we'll let b go off to infinity. So that's our first step. Next, we're going to try to simplify this out, and it looks like they did most of this for us. We're going to put b into the expression, or they put b into the expression, and then they put 1 into the expression. And so what happens if we take the limit as b goes off to infinity? This thing is going to require L'Hopital's rule. So b goes off to infinity. There's two terms that we need to look at that have b's in it. I can tell you now that b goes off to infinity with a negative 12b as a power of the exponential function. That's going to go to negative infinity, and then e to the negative infinity will go to 0, so this thing will disappear. This one is the one that they're going to consider here. This is going to be, if you put this e to the negative 12b in the denominator, it'll be e to the positive 12b, and then so that's how it's going to become L'Hopital's rule. So here's e to the negative 12b in the denominator, and we take the limit as we take the derivative, and so this becomes negative 1, and then this becomes infinity, or the derivative of this thing is 12 e to the negative 12, so I have to divide by 12 after doing a substitution. So I think that's just going to be e raised to the 12b power. And now we're going to let this go off to infinity. This whole thing is going to go to infinity, and 1 over infinity will go to 0. Okay, so that's going to take care of that limit, hopefully. Oh, looks like we got this thing incorrect. Let's take the derivative of this carefully. We would have a 12, and then, oh, I took the integral instead of the derivative. So that's e to the 12b, and then times 12. So it should have been 144 e to the 12b. In any case, it's still going to go to 0. And so we got this thing to go to 0. All right, so what do we have? We have this thing goes to 0, and then we have this thing also goes to 0, because you'll have e to the negative 12b. That's going to go to 0. And then it looks like they took care of combining these two for us, and that is going to be 13 over 144. So I think our result is just going to be this expression over here. Oops. Let's try that again. 13 divided by 144, e raised to the negative 12 power. So regardless of what this number is, it's important for the integral part. But once you know that this integral converges, then we can conclude that the series converges. Again, we don't know what the series converges to exactly. We can say it's approximately equal to what the integral is, but it's not going to be the exact sum. So that's it. I hope that helps.